All right, welcome to day 3. Let me just scroll up so you guys can see that there. This is day 3 on projectile motion. This will wrap up everything we need to know about parametric. We're just doing a quick sort of guide through it, making sure we go, and now we're gonna talk about the application questions. So if you have taken physics, which is like 1 or 2 of you, I think it was just like Ashley and someone else mentioned that they have taken it or like they remember this from a while ago. We're talking the basic sort of like quadratics in a sense, but in our scenario, we're going to convert the quadratics into parametric. So you'll see in a second here. Let's talk about that. And cool. So if you guys are familiar with the quadratic like basics back in algebra 2 with like how projectile motion works, like when you're throwing a ball or like dropping a ball from like a certain height or throwing it off a building at a certain trajectory, these are the equations you're going to be needing to use. Okay, so I'm not going to spend too much time on this except for G, which is going to be this part right here. It's referring to the acceleration due to gravity. And so the reason why you're given 2 different constants here, 32 and 9.8, is that it depends on which units you're using for the problem. So if you notice the problem's talking about like, oh, Jerry is 15 feet off the floor being thrown at this many feet per second, you're probably going to want to use 32 feet per second squared. If it's talking about in meters or in the metric system, make sure you use the 9.8 meters per second squared. Okay? So hardest part about this entire thing is translating what the question is asking you to do. It's word problems all over again. Some of you hate it, some of you are fine with it, and others of you can fall asleep for all you care. I don't know. It is what it is, right? So once we read through all that, make sure you get the general gist here. I'm just going to help you start the problem off. I might just do A, but everything else I'm just going to help you translate what's going on here. Okay? So what we need to first do is read the problem. We got Tiger Woods. I'm not going to highlight that because it's not a hugely important deal. We got initial velocity of 150 feet per second. So notice that's 150 feet per second. And we got an angle of 30. So that means theta is equal to 30. And please make sure you read this top part here, why that's important. Okay, so you might think that's not a lot of information for Mr. Park. I'm like, oh, no, that's totally fine. That is totally fine. Let's go back up here. We need our x parametric. So x parametric is followed by so. This is pronounced V naught, or if you want to say V sub 0. V naught is just a much more conventional way of going about it. You can Google why it's called V naught. It's a whole side story we need to talk about. So V naught is initial speed. Well, we already got that. V naught is 150. So x of t is equal to, let's make sure we get this right here. Yes. V naught is 150. Cosine of theta, we know theta is 30. Cosine of 30 times t. Well, we can easily simplify this out. You know, cosine of 30, if you need to do your trig triangle, go for it. Totally fine. I'm going to break down for you guys because some of you are a little rusty here. That's pi over 6, or 30. Opposite of that, this is going to have to be the smallest side, smallest side, and it's 60. This is the second smallest side, and then that's 1. So cosine is going to be basically the x portion, or that flat horizontal part. So we get basically 150 rad 3 over 2 times t. Or in other words, we get 75 rad 3 times t. There you go. You got your x component. Now let's talk about the y one. This one's the lengthier one, but doesn't necessarily mean it's the more annoying one. We'll see in a second here. So let's start it off. We got negative 1/2 gt squared. So negative 1/2. And we know in this case, because we're talking about feet per second, we want to use the 32 constant up here. We want to use this one. So negative 1/2 32, I believe it was t squared. Just keep going back and forth. Plus v naught sine, very similar to what we had over here. That was cosine. Here it's going to be v naught sine. It's going to be plus, so v naught was 150, sine of 30 degrees, I think times t. Let me just check myself there, make sure we're good to go. Bingo. And then plus h, plus the height. Do we know the initial height? We haven't been given it. Now some of you guys are like, Mr. Park, it's golf. It's on a tee. Of course it's going to be some height. We're going to say for now that there's no statement of the height. So we're going to say plus 0. Let's clean this up. We get negative 16 t squared plus. Sine of 30 is just going to be 1/2 via the diagram over here. Or if you already know your unit circle, you should be fine. Most of you should. It's going to be 75t. And there we go. I'll do the best I can to make sure my t's don't look like the pluses. I know it's hard. I'm going to try to curl my t's at the bottom there. So there we go. We got our 2 parametric equations. It looked kind of crazy at first, but once you kind of break it down, it's very easy to follow through. Now comes the fun part about interpreting the question. Here, letter B says, determine the amount of time the ball was in the air. Let me just make sure we're good. Okay, yeah. So, what are we searching for? We want to find out time. How long was it in the air for? So if we kind of make a sort of, maybe like a quick sketch here. If the ball started here, we know that Tiger Woods hit the ball at a 30-degree angle, kind of like that. So the ball is going like that, but at some point it's going to have to curve and come back and hit the floor. If we think this is the floor here, at some point it has to hit the floor over there. So what we're trying to figure out is how long was it in this trajectory? How long was it going from that original point to this point? And so think, we got three variables. We got t, we got x, we got y. And sometimes you might need to find one variable before you find the one you really care about. Right now you want to find time, but maybe you should focus on what we find first. For example, do we know exactly where that point is going to be? And I think we know. It's some x value, but we know exactly what the y value is. It's 0. So if the y value is 0, let me just write this little hint down. Solve the y of t function if y of t is equal to 0. Basically, I'm saying plug 0 in for the y value, solve for t. You should get two answers because it's a quadratic. Remember, this looks like a normal quadratic. It's just in terms of t instead of x. That's the only difference. Solve for t, you get two answers. One of them should be 0, but the other one should give you an answer. Okay? I'm not going to tell you what the time is. I'm going to let you solve that on your own there. I'm again just giving you the head start here. You then do the arithmetic to figure it out. Okay? I might make up an answer for time here because we're going to probably need it for the rest of the problems, but we're going to hold tight on that for a second here. See, how long does it take for the ball to reach maximum height? So again, you might be like, oh, how long? That's time, right? Yeah, it is time, right? But it's also saying maximum height. So let's go back to our diagram. What does it mean for the ball to reach maximum height? Oh, well, in a quadratic, this is what we call the vertex, right? Or the maximum, relative max, relative min, whatever you want to call it. We're going to call this the vertex, right? So in order to find the vertex, let's go back to our basic quadratics, ax squared plus bx plus c. Do you remember we do something with a couple of those variables there to find the vertex of some sort? Maybe something like negative b over 2a? Just saying. Just saying. So use negative b over 2a in the y of t function. That'll tell you exactly what that height is going to be. And then from there, you should be able to plug it back into, if I got this correctly. So once you find the vertex, because the vertex should give you, in this particular scenario, it's going to give you the time at which it gets there. If I recall this correctly, let me just make sure we're good to go. Yes, it should tell you the time at which it's going to get there. Then you plug in the time into that function again to figure out what the height actually is. Then again, if you read the question, unlike Mr. Park, because I'm not paying attention right now, it doesn't care about the height. It just cares about how long it took. So doing this should give you the time at which that tells you how long it took. You always want to double check, plug it back in, see what happens, go from there. Let's keep going. Determine the maximum height of the ball. Well, Mr. Park wasn't reading letter C, but I was foreshadowing what letter D was going to be talking about. So that's the answer there. I already told you guys about that. And last but not least, determine the distance the ball travels through the air. And so that might be a little confusing because some of you guys may be like, wait, Mr. Park, we don't have any sort of mechanism to be like, how do we calculate the distance of this curve? It's kind of like a circle. How do we determine like the circumference or like how long the curve is going to be? What I'm really asking for is, what is x? That's really what I'm asking for. So for this one, find x when the ball hits the floor again. So you might be like, well, Mr. Wright, when does the ball hit the floor? You know that. You already figured out the time at which the ball hits the floor, and you also know the y value. Maybe use those two in conjunction to help you figure some things out here. So in short, if you remember back to Algebra 2, we're basically doing the same thing as quadratics. The only difference is that we're adding that third parameter, t, time, hence the name parametric, parameter. It's the same root word. That's the idea. So try it for example number 2. Check in with office hours if you need to. If you need help with that, go ahead and just take care of that from there, and you should be all squared away and good to go.